Fusible interlinings are being used with increasing frequency to support outer fabrics and improve the shape and drape of various pieces of clothing. So the following data represents the measured extensibility in percent at 100 grams per centimeter for both high-quality fabric and low-quality fabric. We find that the samples are obtained using a random mechanism. Investigators would like to calculate an estimate for the difference between high and low fabric percent extensibility and test whether the difference is significant. We're going to use a significance level of 0.05. So the first thing that we should do if we're doing this problem is enter our data into our software R. And we could do this by hand, but calculating means and standard deviations and things like that will be much easier using software when the data sets are even bigger than 5 data points. So the first data set or the first variable is high. This is the high quality fabric, and we have the low quality fabric. I'm going to highlight these two sections and run this so I can define high and low quality fabric. You can see down here in my console window, it shows up. And I want to look at this data. So I have two populations in this example. And so what that means is that I have a quantitative variable for each, and I want to compare their averages. So I can look at my data by running box plot, and I can see that this is the high quality fabric. That's going to be the first thing that I run in. So high is going to be 1. And I can make this box plot nicer, but I can at least just take a look at my data and see that it looks like the high quality fabric has a higher extensibility than the low quality fabric. And so that means that just from looking at this plot, I think that our hypothesis test will probably come out with a significant result, because we can see that the higher quality fabric definitely has a higher extensibility than the low quality fabric. All right, we can also calculate summary statistics here. So our mean, standard deviation, and sample size for our high quality fabric. We can see that the mean is 1.845833. We could round that standard deviation, and the sample size for this group is 24. And we could do the same for the low quality group. We can see the mean is 1.37, standard deviation is 0.44, and the length is 10. So our sample size is 10 for that group. And so we could, from here, calculate the 2-sample t-test and confidence interval by hand, but we don't have to. We can use the Ttest command. And if we run this command, we get, by default, a 2-sided test, and the confidence level will always be 95% for the default. And so it's Ttest high versus low. And I get a t-test statistic of 2.7522, degrees of freedom of 18.941. This is the Satterthwaite degrees of freedom, a p-value of 0.0127, and it tells me my alternative. So again, the null and alternative hypothesis for this particular test, because we just want to see if there's a difference between the average percent extensibility, will be mu1 minus mu2 is equal to 0, and mu1 minus mu2 is not equal to 0. So it's a 2-sided test, and so that's what this is, what this p-value represents. And lastly, we have our confidence interval right here. So what's really nice about this command is it just runs everything for me. It's much quicker than doing it by hand. But again, you can get the same results by calculating this by hand. And then we can write up our conclusion quickly. So there is moderately suggestive evidence that there is a significant difference between the average percent of extensibility among the high and low quality fabrics. We're going to reject the null at the 0.05 significance level with a 2-sided p-value of 0.013. So our p-value is smaller than our significance level, which means we should reject the null hypothesis. The p-value is pretty small, but it's in the range of moderately suggestive evidence in favor of the alternative. So that's why we have that first statement that the difference between the 2 quality fabrics, there's moderately suggestive evidence that there's a difference. And then if we keep looking at this, we see that we performed a 2-sample t-test with about 18 degrees of freedom, so the Satterthwaite degrees of freedom. This is the Welch's 2-sample t-test that does not assume equal variances. And lastly, the estimated difference in an average percent extensibility of high quality fabrics and low quality fabrics is 0.476%, so that's the units, with a 95% confidence interval of 0.114% to 0.838%. So this on average means that the percent of extensibility for 100 grams per centimeter of the high quality fabric exceeds the low quality fabric by 0.476%. So it's important to be able to, in context, describe your results. And this is a way that you can do a 2-sample t-test, 2-sample t-confidence interval in R.